Hello everybody, buenas tardes. My name is Bianca Dural Mesa and today I will be demonstrating a science experiment. This science experiment targets the next generation science standard 4/PS3/4. Apply scientific ideas to define, test, and refine a device that converts energy from one form to another. I've actually been working on this standard with my students. We are looking at renewable energy and energy conversions, and the essential question we're trying to answer is how can we prevent blackouts? The learning goals for this experiment are that I hope that my students are able to engineer their own electrical system to have a better understanding of how converting energy generates electricity. Full disclaimer, the materials I'm about to demonstrate are from a science kit provided by my school site. Now, if you're not at a school site or your students are unable to access these materials, then I'll go ahead and link an alternative science experiment below. Those materials are materials that you can find at a hardware store or even in your household. I'll also go ahead and link the similar science kit from Amazon in the description. So, you will be needing a mini solar panel. This mini solar panel has a positive and negative charge. It is made out of glass, so I typically leave this plastic protector on it. It'll help protect it from any scratches. We also have a small fan, a generator or motor, and last but not least, we have 2 wires. And this experiment will be conducted outside since we are using solar energy. But before we do that, I want to go ahead and discuss our science method steps. Our science method steps include 6 steps or 6 stages. We have a question, research and observations, a hypothesis, an experiment where we test our hypothesis, an analysis, and last but not least, a report or conclusion. Before conducting our experiment, we will go ahead and discuss the first 4 steps, which is question. Our question is, how can energy from the sun be converted into electrical energy to power a fan? Some of the research that my students and I found is that solar panels receive or get energy from the sunlight. We also know that solar energy is formed from the sun. And last but not least, we know that electricity can flow from one place to another. Some of my students actually also found that energy is converted from or comes from electrons, what they said, and then they asked what electrons were, but we'll touch that a bit later on. And a hypothesis that we came up with is, I predict that the solar panel will produce electrical energy to power the fan. Now, we're gonna go ahead and test this outside, and I'll see you guys in a moment. Hello everybody, welcome to sunny California. We are in the summer seasons, and I actually live in a very windy city, Fontana, California. So as we see, it's windy, but it's also nice, brisk, 100 degrees out here. And we'll go ahead and conduct our science experiment. What I like to do is I usually like my students to explore the materials before I give them any steps, any directions. This is very self-explored. So I'll usually have students look at the solar panel first, look behind. I'll remind them, hey, a circuit is un circuito, es un círculo, a circle. So it goes round and around, and they usually grab one of the wires. We can connect one of the wires to the negative charge in the back of the solar panel. Then we can connect the other end of the wire to our generator. The generator has two connectors on the back, like so. And then because our experiment is testing whether a solar panel can use sunlight to power a fan, we will place our fan on the top of the generator. Students usually find this out very quickly. I rarely ever have to tell them what to do. And so, most commonly, this is what students do. They don't realize that the second wire needs to be used, but I let them, right? They explore, okay, well, I'm testing whether, I'm testing how this solar panel can convert sunlight to power the fan. Well, right now it's not working, but then we remember circuits. Circuits are circles. And right now our circuit looks more linear than it does a circle. So that's when students realize, let me use the second wire. So you'll use the second wire to connect to the other. You see there's another connector right here that connects to the generator. and you'll clamp your wire. Oops, and you'll clamp your wire to your generator. The end of the wire will connect, put my fan here, will connect to the positive end of your solar panel like so. And again, I don't tell students what to do, but I do prompt them to, hey, hold on to your solar panel first away from the sun. Excuse me, does that do anything? No, and then I tell students, all right, well, test something else out. What can you test out? And most students will say, well, let me turn my solar panel around and see what happens. And they slowly start turning it. And as we see, once the solar panel faces the sun, the fan goes quick, quick, and quick. Make sure to put that fan on the connector properly, it will fly off. And then I tell students, well, do the opposite. You turned it towards the sun, let's turn it away. What does that do? And then they say, well, it's slowing down the fan. Most students will, catch on to it and they'll say, hey, the solar panel is kind of acting like a power switch. And you can think of it that way, right? Our circuit is a circle. It's a pathway that goes round and around. And turning the solar panel will act as a pause in that circuit, right? Well, what would happen if my solar panel was in the shade and my fan was in the sun and I turn it towards the sun? Well, that doesn't do anything, does it? It's not in the sun. Let me go ahead and try the opposite. I put my fan in the shade, turn my solar panel towards the sun, and there it goes again. So again, the solar panel is the power of it all. It is the power switch, and our motor is the energy converter that helps power our circuit. The wires act as our pathway from point A to point B to point C. All right, you guys. So through that, I then asked my students to analyze their data, analyze what they found, and lastly, what did they conclude? So we can conclude from this experiment that my hypothesis was correct. The solar panel does help power on the fan. Now, how does it do that? It utilizes currents and it utilizes the concept of a circuit, the pathway of how energy travels. All right, everybody, I hope you enjoyed that. I'll be linking an alternative science experiment below, as well as a similar science kit, so you guys can all try this. Thank you, everybody.